So here is the ohms calibration section. So I'm going to go through this procedure again. I haven't shown this in video before. Someone actually did mention that they wanted to see me do the calibration. Looking forward to see you do that. Well, it's pretty much the same as this process here, all the way through. You have to do DC first, then you can do ohms, and then you can do AC. I think is it DC, then AC, then ohms, something like that. But you have to do it in the sequence in the manual, otherwise you can have a error. You can't do the ohms first, then do the DC, for example, because otherwise your ohms is going to be no longer in calibration because it's referenced off the DC. So the DC reads the ohms, so you have to do the DC first. Okay, so I try to set this up in a way you can see it, kind of. I'm trying to get it so you can see it, but trying to not get glare on at the same time. I don't know. Anyway, so hopefully you can read that if you've got a big enough screen. So I've got to do this whole shortening thing and going through each step in turn. I've already run through this once before, but that was a couple of weeks ago. I have to remind myself what I need to do. So this is where I need this capacitor and resistor thing as well to do nulling. I think it was on this one. It might have been only on DC. It doesn't mention it here actually, so maybe I don't need to do it on this one. So we've got to do the zeroing on these. 10 ohms to 100k you have to use this zeroing system, and 1 mega ohm to 10 mega ohm you have to use this zero system. Yeah, I found this tricky to implement myself because I don't have their test jig. Right, so I'm using my Fluke here, as you can see. I've got the lights turned down to get rid of the glare, unfortunately, so it's not the best. Unfortunately, I don't think you'd be able to read this at the same time as I'm doing this. I don't think I can get both to work at the same time. You've got a guard, ohms guard and normal guard linked together at this end, and one lead. But this is the thing, they've got this weird lead setup, alright? I completely understand why they've done it. In fact, I think it's a really good thing. But unfortunately, because they've got these odd terminal spacings on here, they're not 19mm apart. You can't just get one of these double leads, shove it in that way instead. You have to shove it in this way, which means you can't actually do this system unless you've got individual leads. I'd rather not do individual leads because they're not shielded. Alright, so this is the one I'm looking at here. They've got the guards linked together at the Datron end, and you've got the highs in the same cable and the lows in the same cable. And then you've only got the guard passing through from one of those to the other end, and then you've got the short across at the other end here, like this, depicted like this. I can't replicate that exactly. I have to do it my way because I don't have cables which can do this particular function because of the connector spacing on the front panel. Bit of a pain, but that's what it is. And obviously this side here is a little bit different again. Still got the ohms guard and normal guard linked together at this end, and still the highs and lows going through both ways. But on this one we've got the high going to the resistor here, and it's linking here as well. And the difference here was it's got this shorting bar depicted across the resistor. So you can see it's got the high link like it is on this one, but it's got the shorting bar linking between the high and the low at the load end, as depicted, right? So I can't do this exact setup because of the cabling I've got. So I have to do high and low one side and I plus and I minus the other side through two separate cables, and that way. And again, I'm going to use local guarding. I'm not going to use guarding at this end. If I have guarding linked at this end and this end at the same time, I do get some measurement glitches. I get a bit of noise and stuff in it. So I have to pick one way or the other, and I found using the guarding at the Datron end seemed to be slightly quieter. So that's what I've gone for. So the first step is in the 10 ohm range. I'll turn the calibration on, you can see by the annunciator over here. And I've got the calibrator set to 4 wire. External guarding, local guarding over here, also on 4 wire. I'm using the ohms guard over here, using a single terminal at both ends, linked together. So yeah, it seems alright like that. We can see the value we're getting on here right now. It's not quite 0, it's just below 0. I'm not going to show how you get a negative ohms reading, but anyway, that's what's happened because of the calibration work we've done on the actual board. So if I zero this now, we should be good. So if you look at this chart here, if you can see it, you probably can't see it now. So it's ohms, 4 wire, it tells you what settings to use, and calibrate key is 0, and that is down here, calibrate 0. And each time you push it, it will get closer, or if you need to refine the value, you can push it multiple times. You don't just have to do it just once. I'm actually going to turn the input filter on as well. So here we've got 0.4014, out by order of magnitude, as Dave would say. So let's give it another 0. Right, it says 0. It's pretty much there, right? Although going -0 is interesting. Might hit it one more time. That's who's made it worse. Don't forget I'm using the input filter. So yeah, that's probably right. If I turn the filter back off again. Let's jump around a bit there. So I might just do a 0 with that without the filter in place. Also got a little bit of noise around the place. Hit it again. This time I'm seeing negative values. Or very little negative values. That's looking pretty good actually. That's better. Look at the filter again. I'd rather have it reading a fraction above, because obviously there is going to be some resistance in the cables. I don't know what the resistance is of actually this whole system with these cables and this unit. It's going to be a bit more than this, I expect. But anyway, I'm happy with that. I think that's close enough. So the next thing we've got to do is the actual 10 ohms setting. So we need to come over here, choose 10 ohms. And we can see we're not too far off anyway. And we just need to do the gain until we actually get a value of 10 ohms. But we can also do keyboard entry. So we can see the value here. Well, you can see how close that is. That is pretty damn close. Right, that's my previous calibration. So I can tweak that, use the keyboard entry and put this value in directly. So we're going to do that. Right, so do keyboard. So we want 10.00239. Now sometimes you just do this more than once. Then you hit gain. And if you do to do it more than once, then that's fine, you just do it more than once. But generally it comes out pretty good. Just give it a little bit of a chance to settle. And I think, it's good enough. That's happy with that. Okay, so now we do the next range, which is the 0.1K. And we do a 0 on that one again. So short that out. So we just do a 0 on that. I'm going to leave the input filter turned on, just for the sake of simplicity. 0 again. It's got negative. 0 again. Just want to get a nice less negative. There we go, that's good, I'm happy with that. Alright, so now we do the 100 ohm range on here, so 100 ohms. And again we've got to try and get the same value we got on here, and well, we practically do. Only very slightly out. I'm actually tempted just to leave it. Yeah, it's a couple of counts. There's a few counts out. Let's do it anyway. Alright, so we got 100.0053. So we do that as gain. And just watch it for a little bit and see what happens. It should be basically stable. It might drift very slightly, but that's looking pretty good. I'm happy with that. Then we do the next one. So we do the 1K range, we 0 that, we 0 this, give it a little while to stabilise, maybe 0 it again, I think I'll 0 it again. Okay, happy with that. And now we put in 1K. And just give it a little while to settle down, make sure it's stabilised properly, and we see it's within 1 or 2 counts of the set value there. Just trying to decide if I should bother tweaking it or not. There we go, it's got 7.8 there. So it's drifting to 7.8 value. I think I might tweak it slightly. Yeah, I think I will tweak it. Okay, so we want 1.000078 gain. Now let's see what it does once it's had a chance to settle. See, now it's actually reading a bit high, so I'll do it again. Okay, happy with that. Am I being a bit fussy? Quite possibly, but I want this to agree with this. That way I can do kind of tracking over time as well, so I can see if it's drifting off and that sort of stuff. So I'm trying to get it pretty accurate at least. Okay, so that's that one done. Now we want to do the 10k range. So we'll do a 0 there. 10k. We'll do a 0 in here, give it a chance to settle for a little bit. It's overshot slightly, I think. We'll hit it again. And then get negative zeros, don't want that. Hit it again. Hit it again. Okay, it's looking good there. So, 10k. Right, so we got 10.00063. Be about 4 counts out there. So we'll probably have to tweak this a little bit. Let's give it a second to settle a little bit more as well. Settling time is quite important because as it changes ranges, you're using different resistor networks and they have to stabilise a little bit. Also using different current sources as well, depending on what you're actually doing. But, that seems to have stabilised to 6.7, so we'll tweak that. So 10.00063. Hit gain. That looks reasonable. Well, that's certainly more 3 than 2 now, so that's an improvement. I think I'll just leave it there. Okay, so the next one is going to be the 100k range. So 100, 0, and no difference in here. It's all the same stuff, so we'll just 0 that. And the higher the resistance, the more settling time you need to give it, because it gets more critical. Because the currents involved, each range up is 1/10 of that previous range's current. So it gets down to nanoamps in the highest ranges, so you're talking really small values, so it gets more affected by things. Hit it again. No, don't go zeros. Or don't go minus, I should say. Okay. Oh, 3.1. One more time. $100k. Wow, look at that. Okay, so 100.0027. So we're out a little bit, even though it's really good, nice impressive value. It's not actually quite the right value. So I need to bring this up slightly, so go 0027. Alright, so keyboard 100.0027 gain. And so what I'll actually do is, in most cases, if you're just hitting gain, it will go between the current point and the target point. It will go halfway, and it will do halfway again and halfway again. If you're a long way off, each time you just hit gain. But because I'm doing the keyboard, it should be going closer to the set value. It's close. It needs doing again. It does increment stuff and set a little bit, so it does need to be done more than once, a lot of times. 100.0027. I'm pretty happy with that. See, when we get to these higher values, then noise becomes more of an issue. So now we need to do the 1000 range, which is the 1 meg range. Zero that, or short that. We'll do a 0 on here. Again, because it's the higher range, it's probably going to take a few minutes to actually let us settle and stuff like that properly. Okay, that seems right there. So let's chuck a 1 meg across there. So I should get 1.000035. So it's actually looking pretty good right now, noise wise. So 1.000035. Correct. Hit gain. Gain. Push it properly, helps. So see, it didn't go all the way there. It got closer, but it's not there. So hit again. Hit gain again. So I have to hit it twice. Why do I have to hit that twice? That's interesting. That's right, because it's doing 1000, not 1, so I need to do 1000.035. That's probably why it's not accepting that when I first do it. And then it's just doing the gaining to the 1 meg position, which is why it did that weird thing there. So that's okay. So I forgot about that from last time. So this, although it's doing 1 meg, it's doing 1000 on here because it's in K. So I need to add 1000.035. Right, so keyboard 1000.035 and gain that one. Let's settle a bit. Not quite there. 1000.035. Again, this whole settling time thing's a bit of a pain, but yeah, it is what it is. And I'm probably being too fussy about precision, but I do want it to match. Like I said, I want to be able to check this drift and stuff later on. So I might just leave it sitting on this for a minute or so. I'll come back. It's about a minute later, and you can see it's drifted up very slightly by a couple of counts. So I'm going to do this again. So probably that very first calibration I did would have actually been good enough. So I think I'm probably just going to leave it there. Possibly. As I say that, it jumps up a little bit. Again, it could be ambient noise. That's the thing. I'll give it a bit more time. Well, I think I'm going to leave it here because it's about right. I'm going to leave it at that position there. I can't. It's drifting very slightly up and down a couple of counts. Just obviously ambient noise affecting it. So I think I'll call that done for that one. So the next one is the 10 meg range. So we'll zero that one out. Give it a minute to settle. Hit it again. Maybe one more. Don't get negative values too much. Go back the other way. Come on. Okay, it looks pretty zeroed there. So now to do 10 meg. So 10 meg. And here we get 9.99987. And because we're actually in the 10 meg range, we've got the same range in here as well. We don't have to do that thousands thing. So that's good. So we can see it's off by a fair bit here. Noise is actually looking pretty good right now. That's quite good. So we'll put this value straight in. So keyboard 9.99987. That's correct, isn't it? Yes. Gain. So closer, we'll do it again. 9.99987. Double checking. Yep. Okay. So again, I'm going to leave this to settle for a little bit, so I'll come back soon. Well, it's been a couple of minutes and it's stripped it down a little bit here. One thing I should mention is this noise is actually a lot better than it was. I was getting more of a variance in this. So I think maybe those calibrations to the actual circuit board has probably helped that quite a bit. Although me touching the wires is upsetting it. Best not touch the wires then. Yeah, even touching the guide wires is upsetting it. So yeah, that's just how touchy this is when you're talking about such minuscule currents in these ranges. So I'm going to do a calibration on this one again. What's it closer? Does that change it? Yeah, so if I sit a bit closer, it changes it. So yeah, it's is it changed because I'm sitting further away now? Yeah, very, very touchy. I'm actually tempted just to leave it there because it's close. I mean, just being near it is affecting it. You know, just me touching the outside of the cable, right over here. Touch cable like that. You know, even that is changing it. It's inducing noise into it, so it's affecting the readings. So I might do one more calibration of this one and then I'll call it a day. So that's not right. What am I doing? 9.99987. And that's gone way out of whack. 9.99987. Come on, get down there. I should have left it alone. It's looking really stable though. But it's not right. So 9.99987. And again, I should have left it where it was. That's what happens when it gets too fussy. Come on, come down. And again. There we go. I'm going to leave it there. Yeah, okay, so that's that one. So that's all the ranges calibrated. That is the completion of that calibration. That's the ohms done. So what I could actually do now is chuck in, if I go to say the 1K range, chuck in 1K. We should get 1K as per this, pretty much, once it settles. So if I do 19, what do we get? So it's slightly out, so the actual scaling is a bit different, which is the interesting part here. I don't know what deals with that part. So 1.900156 0018, so it's like 26 counts out. So yeah, I don't know if there's something else going on there with the ranging or linearity. I'm not sure if there's something I need to look into there. I did notice that before when I was looking at other things. So if I do, that's on the 1K, so if I do 100 ohms instead, that basically agrees. Let's take the 1.9 off. So this is slightly low. So one side's slightly high, one side's slightly low. So the linearity aspect of it isn't quite right. So the middle is right, the bottom end is a bit low, top end's reading a bit high. But you think with the zeroing set up, that shouldn't really happen. Yeah, you have to wonder a little bit. So let's do 10 ohms. That's reading slightly low there, as expected. Right, slightly low there. 100 ohms should be right. Pretty much is. If I do 190, I bet that's reading slightly high. It is. About 26. 27 counts high. See a theme there? So what I'm going to try, just for shits and giggles, is on this particular range here, I'm going to try miscalibrating it. So the manual says to use the middle of the range, right? I'm going to use the top of the range. I don't know if it will work, probably won't accept it because it has to be within a certain tolerance, otherwise it just won't go. So we could try it and see if it will work. So if I'm outputting this value and I try and do a calibration on this one, so I'll try and calibrate to this, shall we? So we do it 190.0107. Alright, so that's what we've got on here. Will it accept it? It did accept it. Interesting. So maybe I can actually adjust the calibration by using the top end of the range. Right, let's try doing 100. What do we get? That's out by about 10 counts. Or 6 counts, 7 counts, 8 counts, 6 counts. So that's an acceptable trade-off. If I do 10 ohms, that's not out by much. It's only about 6 counts out. So I think that's probably a fair trade-off. If I calibrate the top end of the range instead of the middle, it gives the whole range a better accuracy. So that's an interesting little thing to find, isn't it? I didn't think it would actually do that. I didn't think it would handle it. It may still not. Don't know. It may cause an error. Should I do this? I'll do a 10k range. I'll do the same thing on a 10k range. So let's check the short again, make sure it still looks alright. Yeah, okay. Yeah, good enough. So I'll do 10k at 19. That's actually looking pretty close. Anyway, let's do it on this one, and I'll do a self-test because it checks the 10k range. So if I do that, we'll see if it does a self-test failure, and then we'll go from there. Because if it's expecting a 10k reading, it's getting a 19k, it may cause it to fail the self-test. So that's the reasoning behind that. So let's do 19.00102. Set that. It's pretty much there. Let's do 10k. See how we get. So reading a little bit low there. So there's definitely some kind of linearity issue there. It's not a big issue, but it's very slight. If I do 1k, well, that's pretty much it, isn't it? You know, 1k is a bit hard to measure. 100 ohms. See what it thinks of that. Yes, that's very slightly out there, but it could have been due to zeroing as well. Zeroing wasn't perfect in this one. It was going negative, you see. So I might re-zero that. Maybe again. And again. I don't want negative ohms, you can't get negative ohms. So let's go back to the 10K again. Hasn't really affected it, it's fine. So 100 is now reading 100 at least, so that's corrected that slight error at that end. 10K again and 19. 102. It's getting it. So with a little bit of noise affecting it. That's not bad. Okay, so let's do a self-test. Let's unplug these things in case it matters. And do a self-test on this. I think I'm going to do a self-test in calibration mode. If it doesn't fail, that's great. What I'll do is I'll do a calibration basically against the 19 range rather than the 10 range. Error 6. No, it failed. So no, it requires the middle of the range to be set. Well, that's a shame. So I'll do one if there's a way I can get this linearity better instead. I'll have to kind of look into that a little bit. I'm not sure if it's going to be too easy. You might be to do resistance. I can't say it. Might be to do with the resistance values that are in there, may have aged a little bit. Maybe this is wrong. I doubt it, but it could be wrong. I've got no idea if this is accurate. I believe it will be, but you know, who knows? It could be completely off. Maybe that's why it's getting different readings, but it does seem correct on other stuff I've been checking it with. So, and just to be sure, let's do another self-test, just in case it's not that at all. Still gave an error. Oh, that's interesting. We fixed that. And this time when I put it onto 2-wire, it passed. Okay. Let's try something else. So I've calibrated at 19 again. Alright, so I've just done that up here. As you'll see in a second. We'll get there. Alright, so it's at 19 again. So that's on 4-wire. Put it back on 2-wire. Doesn't make a difference because I've got all this stuff hooked up anyway. So it links them together, so it doesn't actually matter. Let's do the self-test again. On 2-wire. Let's unplug that in case it matters. Shouldn't do, but. Passed. Right, excellent. So yes, I can calibrate at 19. Excellent. I'm going to do this again. So yeah, I'm pretty confident it's a linearity issue. So I just did the 10 ohms range at 19 ohms, did that calibration. And if I'm looking at 1 ohm, I'm getting, or it's supposed to be 99966. I'm getting 99943. So yes, it's out by that 20 count still. Not quite sure how I can solve this problem. I'm going to have to look into it some more. If I do back to 10 ohms, that's about 20 counts down. If I do 19, that's now 10 counts down. Ish. Give it a chance to settle. I'll put this one back in again. Okay, back to 10. There you go, so about 14, 15 or so down there. So yes, I've got to sort of have a trade-off here between the linearity and accuracy across the range. What to do? So what I've decided to do is to go back to the DC volts calibration side of it and just verify this and actually redo this part, because the linearity being off on the ohms means the DC linearity may also be off. I've already done this calibration once. I thought, well, I'll do it again. I realised that that capacitor I had before, that was not the right capacitor. It's a 10 nanofarad. Now the DC says a 1 nanofarad. And I thought, hold on, that's not right. So anyway, I've got a 1 nanofarad across here now, and that's a 1 mega ohm resistor. And the idea of this particular stage is to do a linearity adjustment. So I'm still in calibration mode, nothing's changed there, but I'm in DC, nothing's connected across the front. nothing shunt, so I've got it on 2 wire in case it matters, local guard still. So it should be on DC, 1 volt range, filter on, which is what I'm in, and then I should be getting less than 10 digits, as in I mean 10 counts, but I'm getting more than that. So I need to redo this linearity. So let's do it again. Apparently it takes about 30 seconds. Well, it does take about 30 seconds. Or maybe more, a bit less. It varies a little bit, I think. But we'll just let it do its thing. And we should get less than 10 counts on that. So maybe that's why. I mean, I'm getting 27 here. Does that sound familiar? 27 counts? Should it be better than that? Let's do it again. I mean, being 26 counts out sounds familiar, doesn't it? For those other ranges which are out by 26 at the top end. Yeah. So I don't know if this is going to do it or not. It should change each time we do a linearity check. Wait for it to finish. Come on. Must be there nearly. Come on. Must be just about there. Take a little while, as it's supposed to. I'd like to see it get down to 0. No better. Okay. So now I'm wondering if my physical calibration of the board is wrong, because if I had the wrong capacitor by mistake, which I think I did, I may have miscalibrated some of the boards on the analog board. That could have caused an offset, which is causing this problem. It's entirely possible. I might have to start again. Another thing which also could be a problem is that the resistor I was using, which I assumed to be 10 ohm, 10 mega ohm, this one here, I measured it. It's actually quite a way off tolerance. It's more like 11.5, 12 mega ohm. Very different. So the other resistor I found, this one here, it measures exactly 10. Well, you know, within a small percentage, it's really close. So I think I should probably redo the analog board calibrations using this resistor here and redo that section and then come back to this. And we got the idea. I'm not going to repeat the whole thing to show you. You know, you see how to do it, and hopefully I can get these linear calibrations sorted out. So a little bit of time has passed. I've gone through, recalibrated the analog board, just done the adjustments on that one again. They were pretty much right. I did tweak one of the adjustments a little bit, which is R23, which does seem to have an effect on linearity. And on DC at least, that was then bang on. I think I must have missed that adjustment before or something. I maybe skipped over it. I do remember not doing that piece. So that could have been the problem. Anyway, so let's just do this calibration on this part again. We'll see what we get. So I've got it zeroed already. You can see I've got my DC voltage reference running as well. I'll be playing with that shortly. I did that for the verification. So 10 ohms shorted. We've got a resistance value showing up here, so I'll zero that. Okay, on 4 wire obviously. Oh, I'm not on external guard, I should do that. Make sure it's correct. Just don't need negative values popping up. Still not. A little bit of noise issues going on here. Yeah, close enough. Okay, so let's do 10 ohms. So we're slightly off, not much. Okay, so about 7 out. Let's try 19, see what comes up. It's about 20 counts out still, but in the opposite direction. Oh no, it's changed slightly, yeah. Okay, that might be right. Let's just do that calibration at the 10 ohms in. Because don't forget it's a magnitude thing. It's a ratio. So let's do the calibration 10 ohms of this. So let's go keyboard 10.00239 and gain that one. It's around about here. Let's do 19. See what we get. Oh, look how close that is. It's only about 3 counts out. 2 to 3 counts out. Oh, look at that, it's getting closer. There we go. I think I solved it. It was a DC calibration, I hadn't got it quite right. Alright, so I've got this one done. This is the 100 ohms. So it's calibrated. Let's do the 1.9. So it should be 190.0107. And we are basically getting that. Excellent. I just realised I did something stupid. I left the resistor across here for that last test. It was a 10 meg, so I should have had a big effect, but I was going to recheck them and make sure okay. So I was going through the calibration of this thing, just redoing it again after doing the DC calibration again. And I just went to go and do the 10 ohms range, or sorry, 10k range. I changed to 10k on here, and I heard a fuzz sort of sound, like I don't know, a fuzz, some kind of weird sound. It made a little, really quiet, like sort of sound, and everything went off. And the fuse isn't blown, but now it's dead. It won't power up. So I think my resistance calibrator just had a bit of a failure. That's a bit concerning. I want to finish the calibration on this thing. Yeah, looks like it's a bloody power cord. Of course, I just changed cords and it's working. That's odd. I know what it is. I've got a really, well, one of the power boards I've got up here is an Alto brand power board, right? On my shelving, which you can't really see right now. Oh, let's change shots. Right, so up here. So I've got these power boards in here. One here, one here, one here. That's a good quality one. This one up here is a good quality one. This one here is not. And moving it around, things are cutting in and out. I need to change this power board. Ironically, I had exactly the same problem at work yesterday. Power board runs with the computer system was playing up. The computer kept dropping off. Or the network would drop off. Anyway, so yes, don't buy Alto power boards. They're absolute rubbish. Right, these cheap ones, don't get them. I just need to get a better power board for in there. Now I've got everything working again. That was a bit of a pain. Oh well. Alright, so I'm just doing a comparison between the Datron after done the calibrations and the Siglent up there. So I'm just doing a DC voltage calibration because that's nice and easy because I can just hook them up in parallel, not have to worry about it. Okay, so my Fluke DC calibrator here seems to have a bit of an offset right now. It's doing 12 microvolts offset. But you can see the resolution, this is comparable. I was going to go up in, I don't know, let's do 1 microvolt. You can see they're very similar numbers there. 10 millivolts. Okay, they're kind of tracking, right? They're very similar. I've got very low signal levels here, so a bit of noise will affect the numbers a little bit. So 100 millivolts. We're getting a little bit of an error here. I've got a 20 count error. I'm still getting a 20 count thing on here somewhere. I'm not sure it's an issue or not. Let's go up to 190. I've got this thing auto ranging, so I have to mess around with it. So 190.044 and 0.04. I mean, I'm using, if I want a more precision at lower end, I'll use this thing. This is better to a point. It does still have some stepping issues with the digital resolution. The Datron will actually show it up quite nicely because of the stability of it. I was playing with it before anyway. I think the Siglent probably shows it too, but I just haven't noticed it on here, so you can't actually see it. Right, so that's working okay there. Just got a bit of a count error, minor one. Let's do 1 volt. And again, very close, like 10 counts different there. I'll do 1.9 volts, just the max range in this thing. 20 count difference or so just there. But they are tracking together, and that's the important thing, is that they actually are looking like they pretty much match. Alright, so next range up, I'm going to do 10 volts. So you can see there's pretty much the same, 10 counts out maybe. Let's do 19 volts. Again, there's that 20 count difference there at this on the scaling on this thing. So I think that I thought I'd resolved the scaling issue on this thing, but it looks like I haven't. There is a linearity thing where it goes out by about 20 counts towards the end of the scale. So I'm not quite sure what that is yet. Yeah, I'm going to have to figure that out, I suppose. Okay, let's go up to 100 volts. Right, so there's about a 50 count difference here right now. Let's do 190 volts. So, bit of a difference there. 80 counts. Thereabouts. Okay, let's go up to 200. Yep, Datron's looking good there. 300, this thing doesn't work properly. The Fluke at the 300 volt scale doesn't work. I don't know what's going on there. Is it about anything below 340 I think it was, doesn't work properly. Yeah, 341's off, so 350 is okay. Between 300 and 350 doesn't work on that Fluke down there, so I need to fix that one day. But at least I know those particular ranges are problems, so 350, as you can see, is fine. And they pretty much agree. So 400, they agree. 500, they agree. Let's keep on going up. You can see they agree pretty well. Certainly on these high ranges, they're really, the noise and stuff becomes negligible. So, you know, those kinds of positions they get much more consistent. And yeah, so at least the linearity is looking really good. So 1000 volts, and they still agree. So I'm happy with that. At least the linearity side of it's good. On the higher scales, certainly. Lower scales, don't know. There could be some issues with optocouplers still. I'm not completely convinced they're okay. I haven't replaced any yet. Only the one which is missing. So if I start using a PDVS2 Mini instead, let's do 100 millivolts. And here we get that 40 count. Even though I've just calibrated this thing. Maybe it's getting some extra noise coming in through these long cables which are going up and looping around and stuff. Maybe it's adding to it. So it's about 30 count there. So that 200 millivolts. Let's just go to, let's do something different. Let's do, try and do this a bit candidly so you can see the display. Yeah, 1 millivolt. And they pretty much agree. If you look at those, they're really close together. So 100 microvolt. And they pretty much agree. So that's actually really good. They're very close to each other. This is really pushing it. 10 microvolts. Bit hard to see because of the noise that's already there. But I could zero them, couldn't I? Could do a zero there and clear that noise off. This done a zero input, which means it'll go through each range and zero the ranges. Because it's an auto ranging. And that's what it does. And then it comes back. Right. And let's just do a relative measurement on that. You go, by 0 to ability turner, 10 microvolts. And that's showing 16. That's showing 10. 20. This is where the rounding on this thing starts to show up. Because this has got enough resolution to show it. Well, they both do really. The steps are below this, but being digital, it's got some stepping issues there. So that's 2.5 up there and 2 there, or 20. There you go, see a step difference there. Let's go 40. See a step difference there, slightly low. That's the thing with digital resolution. So they are slightly apart there. But you're talking about minuscule numbers here. You know, it depends on the linearity of the ADCs and both the devices and stuff like that. So when you're in this kind of levels, it's just hard to measure. Measuring microvolts, don't forget. So that's 90 microvolts there, and there's 7 microvolts difference between the two. And back to 100 microvolts. So yeah, I thought you might find it interesting, bit of a comparison, especially as very low numbers. Things which aren't easy to measure. You know, if I do 1 volt again, back to 1 volt, exactly 1 volt, exactly 1 volt. They're both pretty happy just there. Right, sorry about the graininess of this. I've got the lights off so you can see this a little bit better. So I'm doing AC volts checking now. I've already done calibration on this before. I'm just looking to see if I need to do it again. We'll see. So we've got the Siglent obviously running AC in parallel with the Datron. I've got quite a long filtering time on this thing. I'm actually tempted to see if I can reduce it a little bit. Tempted to, just to speed it up a little bit. Just make it a bit easy to see, but you get more variation in the numbers, that's all. It's currently set at 0.12 volt range, so we are doing 0.1 volts, so 100 millivolts, and we're getting 99.89 and 99.9 on that one. Right, so not too bad, they're fairly close straight away. Obviously not super precise, but frequencies has a huge effect. So if I go to 200 Hertz instead of 1 kilohertz, that changes it slightly. There you go, that's a bit better, isn't it? If I go down to say 50 Hertz, nice common frequency, so it's changed quite a bit, and this is jumping around a lot more. Right, obviously the averaging of it is not quite so good at that frequency. The calibration on this is done at 500 Hertz, so I'll do that. That's 500 Hertz, and so that calibrated value there should be closer once it settles down. Here we go. This isn't calibrated. I haven't done that yet. This is just prepared. I haven't actually got around doing calibration on it yet. Oh, should we get around to it? Not properly done anyway. I've done it roughly, but it didn't need much. But it needs a bit of tweak. It's not perfect, I don't think. I need to sit there with my transfer standard, my DC calibrator, and do it all properly. One day I'll get around to it. Right, so I'm going to do back to 1 kilohertz again. And you'll see they get closer. Alright, so let's do 1.2 volts, so 1 volts. There we go, 0.9983, 0.9981. Let's do 10 volts. A bit of instability on this thing. It does settle down a bit after a little while. Just that initial range change, it upsets it a little bit. You can see they're fairly close there. 1 millivolt out there. 100 volts. Give it some time to stabilise. You can see they're fairly close here. Once it settles down and stabilises, it's not too bad. Right, they're pretty close. At least they're tracking together. So it looks like the AC side's working okay. Even if it's not 100% precise, because I might have to tweak stuff yet. I don't know. It's obviously 0.2 volt out on the calibrator. Okay, now what I'm going to do is go up to 1200 volts. Well, I'm going to go to 1000 volts on it. But you have to be careful about how you do it. I accidentally settled that as a... Right, do that range. Enable it. Let's do this one here. So it's 200 volts there. Let's build it up to it gradually. The Siglent doesn't like going straight to 1000 volts. If you go from 0 to 1000, it sometimes actually locks it up. So if you go like from 500 to 1000, it's fine. It just doesn't like that initial surge. I don't know what it is. A bit weird. I think there's a firmware update that actually caused that to happen. So I don't know. Maybe Rob, if you see this, you can tell them about it. It doesn't bother me that much. I just know to avoid going to 1000 volts because it's not something you should be doing very often anyway. Anyway, so there's about 0.2 volts difference there. Let's do 500 volts. Also got the filter on here. If I turn the filter off, it'll be a lot quicker. But also you lose decimal place. Not like it really matters that much with the precision I've got right now. But you see you get a lot of noise on here. It's jumping around quite a bit. So I'm not convinced this is okay 100%. I did recap it. Yeah, frequency wise is... yeah. It's probably AC, isn't it? Let's go to... I can't go higher frequency than that. It's the highest frequency I'm doing this thing. At that voltage, yeah, that's it. 1 kHz is the maximum frequency you can do at that voltage. So let's just do 100 Hz instead. So to help set it down a bit. Seems to have helped slightly. Right, now they're a little bit closer, a bit happier. So 800 volts. I do wonder if I should get my Fluke 5200A out, but the only problem is that doesn't do these high voltages. That's why I've got the Valhalla. The 5200A only does up to about 100 volts or 120 volts or something like that. I can't remember exactly what it was now. But it doesn't actually do high voltage, it only goes to the moderate voltages. You need the extra, was it 5215 or something I think it's called, that goes with it. Massive box that goes with it. I think it doesn't like above 800, is it, or 900 on AC, I can't remember. Yeah, just over 800 on AC doesn't like. So there you go, 820 AC. Anyway, they're tracking pretty much, so at least I'm confident this is working okay. Just not sure about the whole noise thing that's going on in places. That's the interesting part. Yes, 1 volt. Bit of a difference in that one. Yeah, do 10 kilohertz. What does that do? That makes it a bit closer. 100 kilohertz. Even closer. Anyway, not bad. It seems to be working okay, so I'm pretty happy about that part. So I think that's pretty much fixed. I'm just not 100% sure about some of the details of it. Just not 100% sure. Give us a thumbs up, subscribe to that stuff. Click the bell icon. Have a chat in the comments. But I'm pretty sure that's mostly fixed. A couple of noisy ranges there, that's the only thing I'm worried about.